Hello, everyone. Thanks for joining us at VMworld 2021. I'm Tony Foster, and I'd like to welcome you to my vBrownBag Tech Talk. It's an update on VDI by day, compute by night, now with more vGPUs. So let's go ahead and get into all the goodies. We, of course, have the ubiquitous required disclaimer for all presentations that VMware is making a show. So I'm sure you can read this, and if you're curious, you can bump back to it at any time. We've got a lot of stuff to get to, so let's get on to it, and let me give you an overview of what we're doing today. Today, we're going to look at a quick review of what VDI by day, compute by night is, and how it works. We're going to then hop into the new features of VDI by day, compute by night, and the script that's publicly available out on the GitHub page. There are a bunch of wonderful parts in there in those new features. Specifically, we're going to talk about dynamic vGPU detection, support for the NVIDIA Ampere GPUs. So lots of goodness there. I know a lot of people are excited about those new GPUs. We're going to talk about some parameter adjustments, something you may not have realized with vSphere 7 and changes in how some of the things function. And then we're going to go into what's next for this script. There are a bunch of different things going on in the background with this script, and I haven't had time to blog about it. So you're going to see how we're speeding it up. You're going to see a little bit of information on support for the NVIDIA A16, and you're going to get to find out about a real application that we're working on for VDI by day, compute by night. Then lastly, we're going to sum everything up with a live demo. So with that, let's go ahead and do an overview for those of you who might not be familiar with the concept of VDI by day and compute by night. In a typical environment, you'll have a graph that looks something like this, where you see at 1 o'clock, 4 o'clock, all the way up until 8 o'clock, you don't have a whole lot of VDI hosts that are in use. At 8 o'clock, it really starts ramping up. And by noon, we're running somewhere around 17 hosts. You can see peak we have somewhere around 20. And it keeps going and ebbing and flowing. You have some folks leaving during the lunch hour and then coming back and increasing the demand of the VDI environment. And then come about 5 or 6 o'clock in the evening, resources begin to come free, and you have only a few folks using VDI. Either they left it running or they're still at the office. And this continues throughout the evening. So if we were to put that in perspective and graph out what our idle hosts look like, you'd see that idle hosts are inverse to what our active hosts are, which is what we expect. And if we say that each one of those hosts has 3 GPUs in it, we can see how many idle GPUs we wind up having in the environment. That's a lot of GPUs that we've paid a lot of money for and we're not really using. In fact, I'd say those are underutilized resources. And this is where the concept of VDI by day, compute by night comes into play. This is the opportunity to use those underutilized resources for other things inside of the organization, specifically using those GPUs. So an overall idea of how it works is really 3 or 4 logic loops to basically see if there are resources available for AI, If there are, then we need to power on a virtual machine. If there are not, then we're either at a steady state and our resources are balanced between VDI and our other workload, probably AI, or there's about to be contention for our AI resources. We need to roll back those AI machines and start up or free capacity for the VDI machines. And so that takes us through our typical environment of how VDI by day, compute by night functions in a logical operation. So let's make this a little bit easier to understand for those that haven't gotten to see it yet. And that is sort of a balance beam comparison. So during the morning, going back to that graph, you'll see that computes are heavy workload. And that morning rush starts coming in. We're going to shrink down our compute workload and expand the VDI workload. And we do that just by suspending our virtual machines. Really straightforward. Everybody's been doing suspends for quite a while. And this tends to put us in a balanced state. So VDI and compute are happy. VDI has all the resources it needs. Compute has the resources that it's allowed, and life is balanced. Now everybody starts going home for the evening, and the excess resources from VDI are again given off, and those are put out to compute. And so we can do things like AI, ML, DL, whatever we have that needs to run against our GPUs in the environment. So we can get quite a bit of power there, and we don't have those idle resources in our environment. So we're regaining time on our investment instead of just letting it pass. So that's VDI by day, compute by night in a nutshell. Let's talk about the new features that you'll see in the script. And by the way, my scripts for VDI by day, compute by night are all available on GitHub. You can find them at github.com/wondernerd. So in the past, the way everything was done with vGPU profiles, we place them all inside of a array programmatically at the start. So you can actually see that in that little code snippet below. So every profile got added in there. And this, of course, led to slower run times because the program was going through and looking, hey, do I have a P4? Do I have a P40? Do I have an A40? What sort of GPU am I working with? And so all of those had to be manually entered. And it creates a lot of extra lines of code in there, especially as more GPUs become available. It was also a manual task that I had to go in every time NVIDIA dropped a new GPU and get all the profiles and stuff loaded into the system. So today, one of the new features that we've added to the VDI by day, compute by night set of scripts is to dynamically detect what GPUs are actually running in the environment and pull their profiles. That way, we're not having to add all of the profiles, even though you're not using those GPUs in your environment. So it's going to remove a lot of the code. It's going to actually speed things up because we're not comparing this to all of the other GPUs that are available. And in the end, it's actually going to result in fewer lines of code. With comments and everything, the code works out to about 160 lines of code for dynamically detecting profiles. If I were to strip out all the comments in there, it actually shrinks down significantly to around 70 lines or so of code. So it's a really powerful tool that hopefully will make things a lot better in the environment. And so this is a supported module. You can find it out there on the GitHub site, like I mentioned at the top. And that supported profiles modules there. You can pull that down along with doing pulls on the other two modules for VDI by day and compute by night. And you'll wind up with a really nice set of VDI by day, compute by night resources that are going to let you do a lot of this dynamically. So you're going to get dynamic vGPU detection, and you're not going to have to go in to put in those new GPUs. So that's something we're really excited about with this. A few other new features. Now, obviously, because we're auto-detecting GPUs in the host, that also means that we're automatically going to support Ampere GPUs. So the A100, A40, and A10 all are ready to go as soon as you have those in your environment. Now, it's worth noting on that A100, the A100 is only supported for compute workloads. So you can't use the A100 for VDI. Just something you want to be aware of when working with this. So if you have two different workloads where you're balancing that aren't VDI, that are maybe TensorFlow and a training system, you can balance between those two with this script as well. You could use the A100 in there. Otherwise, you're not going to be able to use that A100 for VDI. Just a really important note to be aware of. I've had several discussions around that. Then there's the A16. Everyone's super excited about the A16. It's not generally available yet. So that's not going to be something that is initially supported. As soon as the A16 comes out, it should work just fine. There may be a couple of settings that I need to tweak because of the format of the card. So might have a couple of things to tweak there. I haven't seen the final documentation on it yet to know for sure. But overall, it should work without a problem, even though A16s aren't necessarily good candidates for doing AI workloads on. The updated parameters that we've added, there have been a lot of changes to PowerShell with vSphere 7.0. And few folks may not be aware of that or haven't tried doing some of the stuff recently with 7.0 or 7.0 update 2. There were changes in both. But one of the big ones is you're no longer able to stack state or stack states for the get VM host command in PowerCLI. It used to be you could do connected, disconnected, not responding, and send all of those into get VM host, which is one of the core functionalities of the VDI by day, compute by night scripts. And that no longer works. It now only accepts a single state to look for. So you can do connected or disconnected or not responding. And so that's what's been added into the environment. And all of the commands have been updated to go with a connected state by default. So if you don't specify what host type you're looking for, it's going to automatically go for a connected state. So something to be aware of. One of the other interesting things, not necessarily related to this, is you used to be able to suspend virtual machines even if they didn't have VMware tools. And that is no longer the case. You have to have VMware tools installed on a virtual machine to be able to suspend it. And so some of the calls and stuff that are in there to suspend virtual machines only work if you have VMware tools installed. So hopefully, if you're using this, the virtual machines you're using it to manage and suspend all have VMware tools on them. And that's a lot of stuff, but there's still more coming. We're actually going through and working on speeding it up. So get VM host, once you go past about 20 hosts in an environment, can take in excess of 5 minutes to run. That's a lot of time to go through to get results and stuff. And so we're going through and redoing a bunch of code in here, and you'll see this shortly after VMworld. We're replacing it with Git views. And those Git views speed things up dramatically for anyone who does a lot with Power CLI. And we're expecting that around 20 hosts will probably take about a minute to run, maybe even less, depending on the load of the environment. So something to look forward to. I mentioned it earlier. We're going to be supporting the NVIDIA A16 GPU. We're waiting on that release and final documentation to know if I need to make some additional code entries in there for the A16 based on its architecture. Again, like I said, the A16 is not necessarily an ideal solution for compute workloads, so I don't know that there's going to be a huge demand to try and reclaim those resources, but there might. I'd be interested to hear from everyone out there interested in VDI by day, compute by night, as to if they want to reclaim those resources. And then the last thing that we're working on, and I've talked about this in a few other sessions for vMug and a few other places, is a dynamic resource optimizer. And this is going to be a VM-based system with a Python infrastructure or Python backend that is going to do things a lot more powerfully than what you'll see with the scripts. It's going to really get in and enable a lot more integration between systems, such as schedulers like Slurm, or with vSphere and some of the different things you can do through Python. It should really open up the potential to use this as a first-class citizen, as opposed to it just being some script that you're manually running. So we're looking forward to that. And if you're interested in following the development on that, VDI by day, compute by night.com has all of the work that we've been doing with that and how things are going with it. So that said, it's time for a demo, and I know this is going to be fun. This is going to be a live demo, so let's have some fun and hop over to my virtual environment. So here is my vSphere environment, and normally I'd be showing you a bunch of Horizon desktops and everything, but because of time constraints and stuff, and how things don't necessarily power up and power off as quick as you'd like, we're actually going to speed it up and simulate virtual desktops coming online and offline. So we have two PowerShell windows here. This big one's the one we're actually going to be focusing on. This little one is randomly going to power on and off virtual machines to simulate virtual desktops. It's going to power on and off these holding VMs right here. And it'll power cycle those accordingly. And again, in the sake of time, we're just doing hard power offs. If this was a actual non-test environment, what you would see us do is use suspend against virtual machines so that our virtual machines didn't lose all their information. Oh, and so again, the wonders of live demos. We're going to start here and start by turning on our random virtual machines. So it's going to randomly turn on and off holding VM 01 and 02, which are over here on the left-hand side of the screen. You'll see that holding VM 01 is already running. So let's go ahead and kick off that script. And so it's going to start doing random things to the virtual machines that I really don't have any control over. Next, on this larger PowerShell window is the actual screen that we use for VDI by day, compute by night. This is the set of scripts you can go out and download off the GitHub site. And we're going to go ahead and fire this one up. And first thing it goes and does is checks the state of all of our virtual machines. And it's going to go ahead and see what it can do. And it's starting virtual machines to saturate the available capacity of the environment. So you'll see here that we've powered on a couple of virtual machines, Compute 01 and Compute 02. And you'll see that holding VM 01 and 02 are both off. So this is going, hey, I can power on another virtual machine because I have that capacity. So it powers on the virtual machine, and you'll notice that holding VM 02 just powered up. So what's going to happen in this next state is it's going to power off the virtual machine to get that balance back down to where at most 3 virtual machines are running. And it's just going to sit here and keep going back and forth with these virtual machines. So you'll see here we have holding VM 01 and 02 have kicked in. This is going to recognize that both of those are powered on, and it's going to power off a virtual machine to compensate for that so that we still have capacity to run our virtual machine. And you'll also notice that holding VM 01 powered off at the same time. So now there's spare capacity, and it's going to start up those virtual machines again. And it's just going to keep going back and forth in this environment, forcing a steady state across the GPU until basically the loop runs out of workloads, or loop runs out of counts. In this case, it does a count of 15 is what I have it set for currently. So it's going to basically do this 15 times, and then it's going to exit. And the same holds true over here on the random side of things. This one actually does it 40 times, and it's just going to power those things on and off irrespective of what's going on in the environment, just like users do in a VDI environment. So that gets us through VDI by day, compute by night, and a live demo. And I'm so excited that nothing crashed on me during the demo. So let's go ahead and talk about resources for VDI by day and compute by night. Obviously, there's the VDI by day, compute by night.com website where you can find out a lot of information on the topic. You can go there, see what we're working on, see past projects and everything. You can hit up my blog, wondernerd.net, and on there I dive into a lot of the deep technical stuff. So you'll find a blog there about the performance enhancements that we're doing, along with how some of the new modules function and how you can use those outside of the VDI by day, compute by night things. You can go out and download all of the code. All of this code is freely available to the public on GitHub, github.com/wondernerd. You can go out there, get it all, and do whatever you want with it. Use it in your environment. I know the code that I have here is the basis for a lot of stuff that Johan van Amersfoort is working on with some of his clients. So a lot of potential there. You can also join the community. So I strongly recommend you go out to code.vmware.com and join the VMware community. If you have questions for me, you can reach out to me on Twitter at wonder_nerd, or you can hit me up on LinkedIn, linkedin.com/in/wondernerd. And of course, that gets us to sessions you don't want to miss. There are a lot of great sessions this year at VMworld. One of them that I'm doing is Talk Nerdy to Me. We're actually going to get into using Python to create VMs with vGPUs in them. So we're going to dynamically build virtual machines with vGPUs, and all of that's going to be live. So you'll be able to log in and watch me do all of this in my lab with Python. So lots of fun there. The VDI Nerd Fest for all of the VDI fans out there, along with the nerd tours. Then there's Got GPUs, and Got GPUs should be a really, really good session on setting up self-service, which really ties in nicely to this discussion here. And then there are the best practices for running AI workloads, which is something you don't want to miss if you're thinking about AI workloads in your environment. And lastly, there's the vSphere Admin's Guide to Virtual AI Infrastructure for Modern Data Science. I've gotten a few tidbits here and there on that one, and that one sounds like it's going to be a real fun session for AI. So I strongly encourage you to check out all of these sessions. I do thank you for joining me today. Remember to go and fill out your survey. And with that, thank you for joining us at VMworld 2021.